Hey everyone, I am creating an XState cheat sheet, so I figure I might as well just go live and do it live. So that's what we're going to do. Yeah, so what we're going to do is we're going to create an XState version 5 cheat sheet uh, just as a very simple reference for you to look at and be able to copy paste examples and get really quick to that aha moment of, okay, this is how XState works. And this is how I could use it in my code base. So yeah, I'm open to any suggestions that you may all have or anything. Otherwise, I'm just gonna type away. So start with creating a machine. I figure we'll have a preamble here, like this is a cheat sheet that you can mark down. XState V5 data. Refine that later. And Copilot, or rather Cody, is gonna help me out here. I'm not sure which one is active. I think they're both fighting over each other, but I have both GitHub Copilot and also Cody by SourceGraph, and they they've done a really good job with Cody. So if you don't know Cody, and they're not paying me to advertise this or anything, Cody is really good at basically answering coding questions, but relevant to your own code base. So yeah, definitely recommend using Cody, and it's free and open source, which is really pretty great. So let's see. Um, Creating a state machine. Do this. Everything is going to be in TypeScript. So, okay. Actually, I feel like installing would be the first step for any cheat sheet. So installation is pretty simple. The data, you could also use Yarn, but I feel like if you see npm install, then you already know how to do the Yarn thing. Then again, I already have this tab component that I could just use. Let me just go ahead and find that. I had it somewhere. Whatever, just copy this. That's pretty nice. Okay, you could also use pnpm, but again, if you're using pnpm, you already know how to install something if you see a script. Scott says, haven't studied the V5 API at all, so I'm ready to learn. All right, so it's going to be super easy if you're already coming from before, at least in my experience. So after we released XState version 5 beta, I basically went and converted a bunch of our internal machines for testing. And there were dozens and dozens, and the migration is actually pretty straightforward. And for those who don't know, if you go to the docs, and the documentation is at stately.ai/docs, which I'm sure I could find here. Then there is this migrate to XState V5 section, and this shows you just all of the changes. Now, this could be a little bit overwhelming to take in. We do show you the comparison between XState version 4 and XState version 5. But this is something where I hope you could just look at the cheat sheet, and whether you're brand new to XState or just uh, wanting to migrate from XState version 4 to version 5, my goal is to just make that as simple as possible. Okay, so let's create a state machine. So imports, create machine, state. And yeah, const machine equals create machine. I'm going to do a simple, just a simple toggle machine. So we do want to give it an ID and initial toggle. It's, oops, just kidding. Active states. We have active, inactive, and on toggle active, and inactive, on toggle inactive. So be a pretty straightforward machine. Um, I'm wondering if I should beef this up because this is one of those things where you would probably look at it and say, um, why do I need a state machine for this? I could just have a Boolean or I could have an enum or something like that. So just to make things a little bit more interesting. So it counts 0. And so whenever we enter this state, we're just going to assign activated counts to activated count plus 1 to be context, because this is version 5. Well, let's call this counts. Okay, and then you would create an actor. And by the way, in XState version 5, we're changing interprets to create actor. So I'll obviously just release this after we merge that, or after we release that in XState version 5 beta. By const actor equals create actor. You create an actor from the machine, and then you subscribe to the actor, or do whatever you want. You don't necessarily need to subscribe. So a value, and you start it. And then you could send it events like toggle, and it needs to be in an object like that. And then there you go. That's your entire machine. So you could just copy paste this and get it running pretty easily. And you could see what gets logged here. And so just to make it clear, we will actually Copilot's pretty smart, but let's see what this logs. So actually we do start in active already. Q should be inactive. Oh, and the count should still be 1. And then once we toggle again, it should be count 2. And Copilot or Cody gets pretty smart about that. So I think that that's a nice sort of full example. Sort of shows like some of the benefits of using a state machine where we're going between states and we're also executing effects and things like that. So this is a nice concise example, I think. Okay, let's do the rest for like promises and other types of actors. So reading promise logic. All right, so it's going to be a promise, or actually from promise, named a little bit differently. Const promise logic equals from promise, and then we have, I like to do this, just put an async function in there, and then it's a pretty nice, I actually wonder if this works, this Star Wars API. Hopefully it does. Checking it out real quick. So wow, that's interesting. I just realized that if you go to the Star Wars API, it redirects you to Pipedream, and Pipedream lets you do stuff. So it's pretty cool. So I'm just going to change this to API. Although I would really like this to just work. So let me just try to find like a nice free API. Like I think there was one called Dog CEO where it just gives you, yeah, it just gives you an image of a dog, which is always nice. This is not a person, this is a dog. And Yeah, this is going to return something like message. I wonder if this knows what it is. Wow, I'm actually pretty impressed by that. Um, so it will actually give you like an example uh, dog. So that is pretty cool. I'll leave that in there. Like we'll see if that's useful. Um, Okay, so we get the response, we get the dog by calling .json on the response. And so one of the cool things about version 5 is that I mean, this is code that you would have normally written anyway, like this async function that fetches a dog. And to make it work with the rest of the XState API, including uh, just passing it along as an actor ref and invoking and spawning it and having it in actor systems and um, also being able to observe it and things like that with some stately tools in the future, you just wrap that in from promise and that's pretty much it. So now this is a promise that you could subscribe to, which is pretty nice. So we could just create an actor from that, subscribe, and actually I'm just going to move this here. And the snapshot is the response. So it's going to be either undefined or it's the response. And then we just start the actor. So I'm just going to put logs, and then it's just going to log that message. But we could probably make that look a little bit nicer. So do that. And then, yeah, status success. Hopefully. I mean, it's not going to log this exactly, so log something like like that. Okay, so that's promise logic. Pretty simple. Um, okay, let's do more stuff. It's because one of the big things that I really want to highlight with the new docs is the ability to use any kind of logic the same way that you would use a state machine. Now, of course, a state machine, and this is technically a state chart because you could do a lot more than just your finite states. You could have nested states, parallel, delays, effects, invocations, etc., etc. But you should be able to create other types of logic and just interact with them the same way, including receiving and sending events to it. Now, for things like promises and observables, it doesn't really make sense to send events to them, but you could still receive events. And those events, in the case of a promise, it is a success event or a rejection or something like that. And yeah, so let's do another one. So creating transition logic. And I'll just make a note here. A transition function is just like a reducer. I don't know if that makes things more or less confusing, but I'll just put that in there for now. Okay, so we have from transition, create actor from XState, and we are going to uh, let Copilot do its thing. So this is your typical switch statement. So event.type, case toggle. Let's just create a very simple counter. The initial state is over here. So I wonder how helpful that is. But I just want to show that the initial state, that actually probably looks a little bit awkward. So I have no idea where to put this comment. Yeah, but we'll do it there. Okay. So transition logic. You just give it your simple switch statement. And the first argument you get is actually the state. And so everything is just like normal. You switch on your event type. You update the state however you want. Really easy to use immer here, by the way, if you want. And by default, you just return the state. And yeah, that's pretty much it. So we consume it again using the same API. We consume it exactly the same way by subscribing to the actor, calling actor.start. That is going to log count 0. But if we send the actor an event, then you know, get some stuff. We get the count updating. So yeah, this is all the code that you need to really uh this is like Redux wrapped into XState. Or the old Redux. It's nothing like the new RTK, but if you're used to writing this and writing reducers just like that, then you could just pass it to from transition and it's going to work the same. Okay, let's make some more stuff. Uh, Creating observable logic. I'm going to use ArcsJS for this one. So from observable, create actor, and we're going to also import. Wow, it read my mind. I was literally going to say let's do an interval because intervals are it's one of those easy things to understand the power of an observable where it's many values over time, and what better than an interval to do that. So of course, you could do so many more things with observables. Just ask the Angular community. Uh, this one works pretty well. So from observable, XA does want you, by the way, to pass in a function that returns the thing. So this is not the case for the transition logic where you're just passing in that reducer directly into there, or the transition function. Um, but for the promise, you see that it's lazy too. We're passing in an async function that the reason for this is because we want to control when these actors actually start. And that's, by calling actor.start. Now, if you invoke and spawn those actors are started by the machine. So the machine is going to internally just call .start on those actors. But you don't want them starting prematurely. And if you do, then, you could just pass it in. Nothing's stopping you from doing that. So const seconds, never know what to do with the $sign, but you could just do this. Like nothing is stopping you from doing that and from having an observable that's already running. So it's easy enough to do, but we will do it the happy path way. Okay. So we create an actor, we subscribe to it, and then we start it. And again, this is the exact same API. I'm barely typing anything. I'm just letting Copilot do all the work for me. So this is going to, nice. It's just going to log 0, 1, 2, 3, 4, 5 every second. Yeah, I think that's pretty nice. All right. So yeah, these are pretty much full examples. Like you could take this, copy paste it again, and just roll with it. And that's why, like, I sometimes I get a little confused, but I totally understand why people say XState is a difficult library to learn, because it's not so much this part. This part, like, we're trying to make it as easy as possible. You create some logic, you initiate an actor, and then you start it. And then you could subscribe to it, send it events, but that's pretty much the entire higher level API. It's the lower level API, like when using state machines and state charts, that's where it gets a little bit confusing. So I think that's where I'm going to start. There's more things we could create. Well, actually, let me just do callback logic real quick. Do this one. Okay. See what it comes up with. Ooh, that's a nice example. So just a very, very simple timeout. This is changed in version 5. So now, following with the rest of version 5, we're just taking it from a single argument. So from callback, we're going to get send back and receive. And so this, we're going to send back type timeout. Yes. And so this is just going to time out after a second. But just like use effect, we could actually perform some cleanup here. So const I equals set timeout. We could return. Oh, we could do that. I'll explain that in a minute. So callbacks are really interesting because these are really like the free for all, like the really liberal API parts of XState, where if you have something where you need to interface with something externally, and you don't really want to like just go through the rigorous work of converting it to a state machine, then you could just use a callback. And callbacks are great because even though they're not exposing states or anything like that, so you can't really observe a callback, it could have its own internal state, and then it could do things like set timeouts or maybe make a WebSocket connection or do things like that. And you have the ability to send back events to the parents. So this is going to send this type timeout events to the parents, but it could also receive events. And so this is just that function over here. And this function, by the way, is only called once. We're not doing any use effect ridiculousness where we call it twice or anything. This is called once. So receive sets up your receiver so that when you get an event, this is how it's going to respond. So if event.type is canceled, then we clear the timeout. And this is the cleanup function. So if you're invoking this or spawning this and you stop invoking it or you manually stop the actor, you want it to clean itself up somehow. And so that's what that cleanup function lets you do. So yeah. And so now we just have to create that actor. Subscribing doesn't really do anything. But yeah, and honestly, like this makes more sense when it's actually invoked because we need to send it back to somewhere. Um, but at least it could receive events and do things based on those events. So actually, just to make this a little bit more of a compelling example, console.log canceled, and then we're going to cancel it. That's going to just log canceled. Yeah, that's pretty much it when it comes to creating callback logic. Now, there's event observables as well, but those are more of a special case sort of thing. Mostly you're going to be creating observable logic, or callback logic, so you don't really need those. And of course, I could probably just add more links to other places in the docs where you could see those things. Okay, so let's see. Creating a state machine, promise logic, transition logic, observable, callback logic. Okay, so let's actually get to state charts. So I'm going to say, what do we call these? Because we simplified the terminology here. We have state machines, and oh yeah, so we call them parent states and parallel states, initial, final, etc. So let's make an example with states. Oops. Okay. Yeah, this is a pretty simple, parent state example. So active, the initial state that we're going to be in is 1. And, of course, we have inactive. And so actually, yeah, this is a pretty simple example. So basically, the thing I want to show is that when you create a parent state, you're active in the parent state's initial state, and that happens recursively. Hopefully, the recursiveness is sort of implied here, so I don't really want to make this example bigger than it needs to be. Let's just create that actor, subscribe to it, start it, and we will see that the value it's not going to look like that. It's going to look like active 1. So that should show you that we are going to this state. And yeah, so that's parent states. The other important thing is effects, like actions and things like that. So we call them actions. What example Copilot comes up with. Okay. Thinking about this example, do I want to do it like this? Actually, this activate, and then let's call this deactivate. Toggle, we go to inactive, and then on toggle, we go to active. But I really want to show that you could have transition actions too. So this is target, inactive, and then actions. Um, we could have multiple. So I'll just call this notify. And actually, let's just not to make it more confusing. Actually, trying to think. It's the best way to do this. You know what? Let's just call this notify. And then toggle, this is going to be type active, and we'll have an action here too. And this action is going to be just an action object. So type notify message. I am, or just say activating. And then we could just provide those actions. So this would be const actor equals create machine or create actor with the machine. And we're providing the apps, the actions. It's hard to type and talk at the same time. And so we could basically provide the implementation details for them. And notify actually has this as a parameterized action. So we pass it in via params. Otherwise, TypeScript gets pretty angry at you. So, and that's not our fault. It's that we can't really, before we were doing this in version 4, where we had like type is a string and then anything is anything. And of course, when you put any's in TypeScript, that sort of clobbers all the rest of the types. So it becomes hard to say that the parameters have to have a specific shape, or that the types have to be these exact types, because once you start saying that any property could be anything, then TypeScript just has a free for all and does whatever it wants. So that's why in version 5 we're putting everything under params, and it's a little bit cleaner too. So, okay, notify, add the action. And so we're going to just console.log action.message, or just default message. Because remember, we do have an action, a notify action that doesn't have any sort of message passed into it. Oops. Not params.message. Wonder how that looks so far. Should probably do some highlights. So, what it was. There was a way to like just highlight something in Markdown. Let me look at that up real quick. Let's figure it out. Or not highlight something in Markdown, but rather in DocuSorts. Aha! So it's just highlight start, highlight end, highlight next line. It's pretty nice. That's one of the features that I really, really like in DocuSource. So if you didn't know, you could just add this highlight next line comment, and then it just highlights it for you. It's pretty nice. So do it here too. And we will do it. This will be a highlight start, highlight end. You could also like fence in these blocks to highlight. So yeah. So we're showing off entry, exit, and a couple of actions. So let's see if Copilot is smart enough to actually do the right thing. And we actually don't need to subscribe because our actions are taking care of all of the side effecty stuff for us. So when we first get into active, we do want this activate um, action to do something. So Copilot's smart enough; it knows what's happening there. So now when we send toggle, let's see what happens. Okay, so it logs deactivating, which is correct, and it's also going to log not activating default message. Okay, let's toggle again. Now it logs activating. Actually, that's okay. So activate logs activating. Sort of confusing myself. I probably um should have done something else. So instead, over here, uh, on notification. Notification because this is our transition action that we're taking, and we're also going to get into the activating, or sorry, the active state. So that is, I hope that's a concise enough example. Yeah. All right. So that looks pretty good. Uh, okay. Let's get the guards. Again, it read my mind. Just gonna think like we need a good guard example, and this one should be fairly simple. So guards. Okay. Chain. Let's see what it comes up with. All right. So let's make this a little bit simpler. This is trying to do is even, is odd. But instead I want to say um I want to toggle, or I want to toggle to go to, see, okay, let's do this. Context, um can activate and set this as a permission. And so we're actually going to start in inactive, and hopefully the order doesn't mess anyone up, but I'm going to just switch these around. We're going to say inactive, and then on toggle, we're going to go to target if we can activate it. Or we'll just say can be toggled. I want to name it a little bit differently and then provide that in const actor, create actor, can be toggled, context.can activate. Perfect. Okay. So, yeah, just need to highlight the next line for that. Okay. So, it's going to go to the active state if it can be toggled. So, if, and we don't really need to do the rest. I just want to show that example going from inactive to active, um, based on that guard. And again, that should be guard because we're in version 5. All right, so you could go to active if it can be toggled, and that's going to just check can activate. Okay, so just need to show that as an example. And actually, I want to do something real quick. I want to show that this is where you would use a transition array, or where you can use it in case you want to do something different. Target inactive is where it's going to go anyway. So let me do something a little bit more interesting and just say define not allowed. then we could just add that here. Makes it, again, more of a compelling example. So cannot be toggled. By the way, if you're using XState with Copilot or Cody, it's the easiest thing in the world. It just does everything for you. It's pretty nice. So let's start highlighting just the guard here. That way we could easily see what's happening. And let's subscribe just to see what happens. Actually, we really don't need to, because what we could do is just call actor.start, and that's going to log cannot be toggled. And it's not going to transition. It's just going to stay in that state because we're notifying not allowed. So I think that works pretty well. Okay, so we have actions, we have guards. See, the the very important thing is invoking actors. So this is sort of bringing everything together. And this is like advanced XState where you really, really get the most power out of XState. So imports, going to create a machine, and we're going to have from promise and create actor from XState. And so our promise is going to be pretty simple. Just call this load user logic. And this is just going to be, oh, I wonder what that gives us. Well, it gives us a just a random user. I really hope that that's not a real user. I'm just, Okay, so it's a placeholder. That is very, very cool. And at least you could copy paste this and see it working immediately. So that's actually pretty nice. All right, so we have our load user logic. We have our machine. And actually, it just did everything for me. So ID load user, source is our load user logic, which is that from promise over there. And you could honestly just inline it like this if you want. That's what I usually do, but it's over here. So, don't really need to do anything else there. And I actually want to save the user. I think that that's important, especially if you're using XState to execute tasks. So we start with our user being undefined, and then we could just assign, which please remind me to import it. And we just get that from the events. Now in version 5, that is destructured from here. So yeah, just checking. And that entire user is going to be our data, which is passed into the event over here. So, or actually, sorry, this is output. So in XState, and I'll add a section here for that soon, but there's this idea of input and output. So every actor can have input, and it could also have output. So the output would be something like if this top level state was type final, and you have an output, and your output, you just wanted it to be the user. So that's what output would be, and that way you could consume that output. You know, but we're not going to do that in this example. All right, so we have that, and actually, you might be thinking like, why do we need to recreate all of these states for something like this? You don't technically need to. The reason that you would model a machine this way is because if you wanted, like, let's say the success was another step, like transform that user data somehow or send it to Slack or Discord or something like that, these are the states that you would do it in. So, you know what? Just to really exemplify that point, the target, I'm going to make it do something with user, and then we could just do whatever. And then failure, we just have that there. All right, so let me highlight this. Right start, right end. Okay, cool. So that's our invocation. And then we are going to create an actor, subscribe to, um, actually, let's subscribe to not the value, but the context.user. And we just start it. And then eventually logs, this is going to be our user, which this is really interesting because this is the actual name that comes from that API. So at least when you run this locally, you're going to see like, oh, hey, yeah, it does give me ID1. It gives me Leanne Graham. Um, so that just works. The slap off asks, does XState version 5 beta work with the XState View package? Yes, it does, or at least it should. So, yeah, packages, View. Yeah, XState version 5 should work with Vue. Now, keep in mind, we actually do have to do some updates to Vue. And by updates, I mean we have to just rename a few hooks because use actor is going to mean something a little bit different because the original usage of it in V4 is a little bit redundant because in version 4, and this is for both X8 React and X8 Vue, etc., use actor, you passed it in an actor, and then you got the state and something to send it. But you really don't need to do that because if you have that actor reference already, you could just use selector and grab the state. And if you want to send an event, you already have the actor ref, so you could just call actorref.send. So yeah, we just have a little bit of renaming to do. I think that's one of the final things to do for packages like Vue, Svelte, etc. So yeah, let's go back to here. But yeah, thank you for your question. The slap off, I'm getting dependency errors while installing the Vue package. All right, so if that's happening with version 5, make sure to install at xstate/view at beta. So hopefully that's in here. No, it's not. Okay, so let's just make sure we're on the V5 docs. So let's do V5 xstate view. Let's make sure these are up to date. Okay, thank you so much for telling me state at beta and xstate view at beta. If you're using view 2.x, I'm going to get rid of this one just because I'm not sure, or I'm pretty sure that X8 View 2 does not work with X8 version 5. So, um, yeah, data. So yeah, just doing a few updates. Uh, contains utilities for using Xdate version 5 beta view. And then, okay. So this is a little bit of a tangent, but that's okay. It's something that we need to do anyway. You send event objects. That's another one of the themes in X8 version 5 is that you're not sending plain strings because we would rather you have a nice consistent API throughout. I'm not sure why view highlighting isn't working, but maybe it's because it's DocuSource and maybe DocuSource isn't the biggest fan of view. I'm not sure. Not sure how to get that working, but yeah. Everything else is still pretty much the same though. So it's machine options. This is going to be an actor, not a service. But I'll get to that eventually. Oh, I didn't realize that this banner was still there. Sorry about that. Okay, so let's get back on track. We were invoking actors, and so that's what that looks like. And now let's actually get to spawning actors. Another pretty simple example, and it's going to feel pretty much the same as invoking actors. Let's go ahead and just copy this example. And actually, this should be a little bit of a simpler example. So this is just going to use the same thing. Const machine equals creates machine. And since we're spawning, we're actually going to save it in context. You actually don't need to, but we don't have an action for just spawning a one-off actor that doesn't live in context yet. So that's something that we have to create. Um, so let's just make context, and this is just going to be the well, let's call it the user ref, and this is just going to be undefined for now. And then we are just going to uh, actually, it's funny. We don't even need states for this one. That's how simple this example is. So on load user, actions assign, and we are going to assign the user ref, and we're going to spawn the load user logic. But this spawn actually comes from here. And that allows us to be more type safe about it, etc. And this is all you need. This is really all you need. So yeah, what's cool about that is that in a React component or something, you could basically just select that user ref, and then once that's available, you could select the value from that. So pretty useful. Uh, let's actually see what Copilot gives us. So we create the actor, we subscribe to it. This is pretty nice because we get the user ref from context. Actually, I'm just going to say const, just making this a little bit nicer. User ref equals snapshot.context. And then we're going to console.log. We don't have a state value. This is an actor. So we get the snapshot from that. See how consistently we name things? We have snapshot here, and then we have snapshot there. So you could think of an actor system as a tree of actors, and to get their latest emitted value or their latest emitted snapshot, it's get snapshot. And so that's why having like from promise, from callback, from observable is really useful because all of these actors share the exact same API. And you could create any sort of custom actor that you want. Okay, so when we start this and we send an event like load user, this is going to eventually log your ID, your name, Leanne Graham, etc. And just works. I don't know if condensing these is going to help, but I'm going to just group these together. And also we need to spawn this. Or sorry, we need to highlight it. Okay, so again, we have a bit of a simpler example here, which is pretty nice. Oh, we forgot a sign. I think we forgot a sign some other place too. Yeah. Just find all of our signs over here. This won't happen in real life because hopefully the IDE you're using is smart enough to just do it for you. All right, I think we're good. All right, so that's how we spawn an actor. And of course, the thing I promised, which is input and output. By the way, if you're just joining in or if you've made it this far, I can't believe it's been 48 minutes already. The only thing you really need to get started is this part right here. Like this is all you need. Just copy paste that, run it in your code base and see it working. It's literally that simple. And it gets even simpler for other types of logic if you don't need the full power of state machines. So you see like a transition function is pretty much the exact same length as you would write a normal reducer or transition function normally. And you just create an actor from it, which you could subscribe to, and you start it. Yeah. So all of these are meant to be copy paste examples where you could just throw it in somewhere and have it working immediately. Now, what I would really like to do, and I keep forgetting the right way to do this, is to have it so that I could basically copy paste this in the browser console and have it work. I think we need like special types of imports or something, or like an await to import type of thing. If anyone could give me a like pointers on how to do that, that would be really cool. Otherwise, what I would also do is probably, since I'm using DocuSource, I could just globally load XState and attach it to the window so that you could copy paste these examples, or at least going from here down, and just see it in the console and then just be able to run it immediately. So that's a future goal, but we'll see how far we could get with this today. All right, so last thing I'll do for today, I'm going to do input and output, just because those are very, very important concepts. And it's probably one of my favorite new features in XState version 5 is that you could model those. Um, okay, create machine, create actor. Let's see what kind of example it comes up with. Toggle, no, do something different. Create machine, oops. Okay, let's help it out a little bit. So input, and I'm just going to say message hello input.name. Perfect. Yeah. So that's exactly what I wanted it to do. And then on entry, I'm just going to log that. So, but it's not going to come from output. It's going to come from the context. So it's just going to log context.message. And yeah, actually that's all we need. So create actor, create machine. Where do you put input? Well, you put it where you create the actor. So the input in this case, it's going to be like name, David. You could have other properties that are going to get ignored. And that's why input is better than the awkward thing that you had to do with context before, which was dot with context, and you were overwriting context and you needed to know the exact context values. And it was very inflexible. So at least with input, you have a way of just strictly defining that we're going to take the input and we're going to just create our own internal context from that. And it's a lot safer that way too. Okay, so we have input named David. Let's highlight that. Like start, highlight, end. Then we demonstrate input over here. So we're going to start and end that highlight as well. You can see it over there. Then we start. And this is going to log hello, David. So that just gives you an idea of how you could use input with logic itself. And this works for any logic, by the way. And I think one way I could show that is by invoking with input and output. So invoking actors with input. So nah, let's do from promise. Okay, we're going to have the same load user logic, except this one's actually taking an input. You can see right there. So we're going to create a machine. Don't really need the user now just because we're going to just demonstrate this by logging. So initial loading or loading user. States, loading user. All right, so we have the load user logic. And how do we provide input into this though? Well, we need to just pass it in through here. And so ID is going to be 1, or let's make it 3. I'm really curious to see what person number 3 is. Don't really need this. We could just put it on done. So actions, let's grab that event and let's log the output. Okay. Now we create that actor, we start it, and this is going to eventually log Clementine Bach. I wonder if that's correct. Literally just going here and checking, and I don't know if you could see it that well, but that is indeed Clementine Bach. So that's fun. All right, so just to review, in under an hour, we created a cheat sheet where we create a state machine, create promise logic, transition logic, observable logic, callback logic, parent states, actions, guards, and then we could invoke, spawn actors, input and output, and we could also invoke actors with input. And the output is what the actor returns. So, we already have that in there. Now, this is just honestly the tip of the iceberg. This is for you to pretty much do 98% of whatever kind of complex logic you want to do with XState. There's so many other features, and maybe I'll include them in the type sheet too, or sorry, the cheat sheet. Just let me know your ideas of what you want to see. So yeah, I'll end it there, and I'll probably put this as a draft PR. So if you want to take a look at this, this is open source, by the way. And so let me just get you that link. If you go to github.com/statelyai/docs, I believe that that's where you'll be able to find them. So yeah, again, please let me know what kind of things you would love to see in a cheat sheet. Um, I was actually thinking of making a single cheat sheet just for everything that you could do in a state machine in a single state machine. I don't know how complicated that would get, whether it would be easier or harder to read, but I've always wanted to do that. Just make a single omni state machine where it has parent states, parallel states, history, final, guards, transient transitions, actors, invoking, spawning, etc. There's just so many concepts, but XState does give you a lot of tools that you could play around with. But hopefully, this cheat sheet goes to show you that you really don't need all of that. You could just copy paste these examples and get going really, really quickly with any kind of logic that you want to use. So, yeah, want to say thank you all for watching, and I'll cut it there. See you all.